Welcome to Chapter 9, Roots and Radicals. In Section 1, we'll be talking about finding roots. Hopefully some of this will be a little bit of a review. Same with any math topic, but especially this one, I find that students get better with more and more practice. So give yourself as many opportunities to practice different problems as possible. It will start to click. And of course, bring any questions you have to class. So let's do a little bit of vocabulary here. When you see a root of a number, the entire thing itself is called a radical. So we're looking at a radical number here. The little check mark with the extended top, what I'm highlighting here in pink, is known as the radical sign. That's the symbol that we use to indicate that we're finding a root or we're taking a radical of a number. And then whatever is underneath, whether it's a number or whether it's variables or whether it's some sort of combination of numbers and variables, that piece is called the radicand. I won't be testing you on these terms. You won't have to write out definitions or anything, but you will need to be able to recognize them when they're used in directions and be able to know what is being asked for. So let's do a little bit of review here. We recall that multiplication is really repeated addition of the same number. 3 times 5 is 3 groups of 5. It's 5 added together, 5 plus 5 plus 5, 3 times. So that's what multiplication is. And to undo multiplication, we learned an opposite operation. To undo multiplication, we would do repeated subtraction, or what we learned to call it division. Okay, so division undoes multiplication because division is like repeatedly subtracting the same group away from it, and or dividing it into groups. That may have been how you were taught, because multiplication is repeated addition, quick addition of the same number. In the same way, exponents are a way to represent repeated multiplication . Repeated multiplication of the same number. And if you have an operation, you can undo it. There's always an opposite operation. So with exponents, it's repeated multiplication of the same number. To undo that, we would do repeated division. Sorry. Division of that same number. And we know that to be finding roots. So for example, if you had, how to undo it, finding roots, if you had an x squared, the opposite of that, sorry, this would be the x squared, that's x times x. The opposite of that would be to take the square root of the x squared, and that would get you back to x. So you can take x times x, write it as x squared. To undo it, you take the root of that, the square root of it, of x squared, and that would get you back to just plain old x. When you see just a plain radical sign with no number out front here, that is assumed to be the square root, the index of 2. Okay? Whatever number appears here is the index. So it could be a cube root if there's a 3 here, or the third root. It could be a 6, a sixth root, and we'll look at what that means as we go a little bit later on. But just to give you an idea, when there is no number, when it's blank, it's the square root that you're trying to find. Something times itself gets you back to that original number under the radical, the radicand. Pardon me. So let's take a look at what happens when you start to involve negatives. So the instructions say to evaluate each expression or state the expression is not a real number. So again, when we start with number 2, radical 16 or the square root of 16, we're looking for a number exactly times itself that will give us 16. And these two exactly, they have to exactly match. And with no sign out front, we're looking for that positive value that does that. So in this case, the answer is 4, because 4 times itself does give you 16. Okay? And when it's positive, this is known as the principal square root. The first and foremost square root. When there's a negative out front, remember that we've been talking about that negative really indicates it's -1 times whatever it is, in this case radical 16. So radical 16 is still 4, so our answer here is -1 times 4, or just -4, and this one is known as the negative square root because of that negative out front. Over here we had nothing out front, and that's what made it positive. Okay, so we've got a positive square root known as the principal square root. We've got the negative square root because the negative's out front. But then when you put the negative on the inside of the square root, as in number 6 here, radical -16, again, going back to the definition of what square root is, we're looking for something times itself have to exactly match that would give us -16. And there is nothing, there's no two positives that you can multiply together to get a negative. And if you were to have two negatives, -4 and times -4, that would give you a positive 16 as well. And you can't mix and match. That's not what square root means. Square root means is that you're back to the original item, because we're undoing the exponent here. The original item multiplied by itself would get you back to this -16. So this is not a real number. Okay, so that's what you'd write as your answer, not a real number. They'd have to exactly match, and you can't do it with a negative as your radicand, the number underneath the radical sign. So they take you through a few of those where you get to practice with the principal square root, the negative square root, and then not a real number. Anytime there's a negative under a square root, it's not a real number, okay? And that's a square root. We'll talk about other roots as we get going, but let's just remember we're dealing with just the square root right now. Let's move on. Let's look at number 16. What's different about number 16? Square root of 0.64. There's a decimal here, okay? But we can still find square roots of decimals. What's different about 14? Fraction. We can still find square roots of fractions. We'll get to 14 in a minute. Think of 0.64. If you were to convert that to a fraction, what we'd be looking at is the square root of 64 over 100. And one of the things we are going to be learning and practicing in this chapter is what you can do with radicals, how you can split it, how you can divide it up. And so we'll learn that rule a little bit later, that you can actually split this top and bottom. But can you imagine what fraction times itself would have given you 64 over 100? That's what you're trying to ask here. Well, multiplication of fraction is top times top and bottom times bottom. So top times top having to be exactly the same, again, have to exactly match. To get 64, the top times top would be 8. 8 times 8 gives you 64. What would be on the bottom to exactly match to give you 100? Well, 10 times 10. So the square root of 64 over 100 would be 8 over 10. As a decimal, that equals 0.8. So radical 0.64, square root of 0.64 is equal to 0.8. And if you were to test it in the decimals, 0.8 times 0.8, old school, lining them up decimal wise. Of course you can go to your calculator, but why not make your brain a little stronger today? Try it on paper. 8 times 8 is 64, carry the 6, and you don't need to multiply the zeros too, but you do have to move that decimal 2 places over. 0.64 is your answer. So I'm sorry, I should not have done the square root here. The answer to radical 0.64 is equal to 0.8. Here, I'll just make it a cute little picture frame. Oh dear. Okay, let's look at 14. What's different about this one as opposed to the others? Well, there's a fraction involved. Well, we've already discovered you can do that. However, there's a negative in front of the fraction, and we can't take the square root of a negative when there's no number in the index spot. Maybe, oh, and you know what? I realized I'm down the page. Sorry, I'll readjust here in a minute. Let's go back to the top here, though. The number that is here is called the index. And it indicates which root we're finding. I often forget that the camera won't cover the whole page, and I get going and I get excited. I'm such a math nerd, and so I just keep going down the page. Indicates which root we're finding. And then if it's blank, that means we're doing root 2 or square root. Okay, so I will stop this video, readjust the camera, and then we'll talk through those ones again.